Lung cancer is a type of cancer with the second highest growth of new cases. In 2020, 2.2 million cancer cases was recorded. Lung cancer also ranks as the highest mortality rate with 18.2% of total 9.9 million deaths by cancer was caused by lung cancer. Early detection is crucial for improving survival rates. We can go with new approaches such as AI. The application of artificial intelligence in the medical field is still limited in Indonesia, but it shows promise for lung cancer diagnosis. Hence, we created a more accessible early-stage diagnosis and advanced-stage diagnosis that use artificial neural network and convolutional neural network to predict lung cancer. A deep learning model that is trained by analyzing datasets in the form of a website accessible to everyone.
My name is Gibran, Tegar, Ramadhan, Putra, Lynardi.
And my name is Musyaffa, Abhinaya.
We are from Muhammad State Prominent High School. We are going to present to you our research entitled
Lung Cancer Diagnosis Application Website based on Hybrid Learning,
Artificial Neural Network and Convolutional Neural Network. This study is aimed for improvising lung cancer diagnosis by integrating artificial neural network and also convolutional neural network in a form of website that is accessible for everyone. This research will be conducted on November 2023 to February 2024 in Muhammad Computer Laboratory and also dormitory. We use Python as the programming language, Google Collaboratory as the IDE, Anvil and Canva as the website builder. For artificial neural network, we use a dataset consists of 300 items, 260 of patients diagnosed with lung cancer and 40 without lung cancer. Also, the 10 parameters we use are gender, age, smoking, alcohol consumption, yellow fever, and shortness of breath, fatigue, chest pain, swallowing difficulty, and also wheezing. For convolutional neural network, we use 1,097 items of patients with their CT scan, 416 with normal cases, 561 with malignant cases, and 120 for benign cases. We obtained all of these datasets from a public domain named Kaggle.
Artificial Neural Network, or ANN, is a mathematical model inspired by artificial neural networks that can predict how an ecosystem responds to changes in the environment. ANN consists of input layer, hidden layer, and output layer, connected through weights, biases, and transfer functions. The process begins with the initialization of weights, followed by the calculation of neuron activation using mathematical function, and adjustment of weights to obtain the desired output. Here are a few hyperparameters we are using for our ANN program. We use 3 layers with the number of neurons set to 32, 64, and 128 respectively. The ReLaw activation function is applied to all layers, except the output layer where softmax is used. We use the default optimizer from Keras, which has its default learning rate. This optimizer provided by Keras basically employs a backpropagation algorithm with SGD. We set the batch size to 16, the number of epoch to 200, and the validation split to 0.3.
The following are the results of the ANN program in graphic form.
The lost epoch graph generally shows a decreasing trend, particularly in the initial intervals, with the most significant decrease observed in the first 20 epoch. Subsequently, the decline stabilized, remaining relatively consistent at levels below 0.005, indicating minimal loss. The accuracy epoch graph displays a consistent upward trend, notably pronounced within the initial 50 epochs. Subsequently, the accuracy stabilized at levels above 0.975 and below 1, indicating robust performance. For the val loss epoch graph, initially the graph experienced a decline until approximately the 10th epoch. Subsequently, the validation loss increases notably with epoch progression, indicating significant changes. The average total loss is 0.7515 and an average gradient of 0.0025. This suggests the ANN model is overfit. For the val accuracy epoch graph, the graph exhibits an increasing gradient with epoch progression, averaging at 0.003475. Additionally, the validation accuracy rises steadily with epoch, consistently exceeding 86%.
For the convolutional neural network, there will be some stages of procedure. First, there will be training and testing the dataset that have been received, and finally, the evaluation of the classification report of the model's performance. The model program has several stages. First, we are going to import libraries that we need, and then we are going to mount Google Drive for the dataset that have been received, and also we are going to define dataset path, and then we are going to load images, and then we are going to do model defining, compiling and training, and finally prediction and visualization. The performance of the model can be observed over 100 iterations, showing that it runs quickly with a learning time of approximately 3 seconds per image. The classification report metrics provide insight to the model's performance. The accuracy metrics indicates that the model excels in classifying groups to diagnose lung cancer. Candidates can use our website to check if they might have lung cancer. They just need to answer some simple questions. If they have a CT scan of their lungs, they can upload it too. Our system will then tell them if they have lung cancer or not, and if they do, it will say if it's normal, benign, or malignant.
Based on this research, it can be concluded that both artificial neural network and convolutional neural network offer promising avenues for diagnosing lung cancer with high accuracy and performance.
This model also demonstrates a significant improvement in accessibility of lung cancer diagnosis compared to traditional methods, such as relying solely on a website for diagnosis.
That's all from us. Thank you for watching our presentation.